is quickly becoming relevant for you as well. And GraalVM really is something great. And I hope to convince you of that over the course of this presentation. First, a little bit about myself. My name is Lucas Jellema. I live in the Netherlands, not too far away, and I regularly visit Germany. Unfortunately, not this time, so I'm sitting at home in Zoetermeer, which is close to The Hague in the west of the country. I work at a company called Amis. We are part of a larger organization called Conclusion. I'm CTO at Amis, and I'm also a cloud solution architect. I've been involved with Oracle since '94, working with Oracle technology, and as such, I've been nominated both Oracle Ace Director and Oracle Groundbreaker Ambassador, and that's for spreading the word about things like Graal. So let's dive in. This is how software typically starts out. It's structured, it's clean, it's not messy or tangled at all. But we all know what software looks like after a little while. That's the bane of our lives. I'm not sure it has to be, but for now it typically is. And even Gartner, the analyst company, has said something about that. The lifetime of a software application over time, the cost, complexity, and risk increases, the fit, the value, and the agility of applications decreases. We go from uncooked structured spaghetti to the mess we see on the right side. So why am I talking about this? Well, because I want to talk about the JVM. And the JVM is one of the greatest pieces of software ever created. It's the Java virtual machine, and it has been running Java applications for a long time, everywhere. And you probably know that Java is special because, well, for example, because you write it one time and you can run it anywhere. There are JVMs on almost any platform imaginable, and that's a very special aspect of Java. There is another aspect of Java that we don't talk about so often that's also extremely special, and that's that over time, your Java application will start to run faster. So it's happily ever faster. And why is that? Well, because in this JVM is a special type of compiler, and that type of compiler kicks in when the application has been running to optimize the application as it is running. And this compiler, the C2 compiler, that's really the subject of this talk. Well, it's one of the subjects of this talk. So this JVM and this C2 compiler was launched in 1999. And 1999, as you're all aware, is a long time ago. So this JVM, this wonderful piece of machine, has gone through one cycle of 7 years, a second cycle of 7 years, and a third cycle of 7 years. And of course, the cost, complexity, and risk has increased tremendously over that period of time. It has become harder and harder to further maintain the C2 compiler. This essential piece of software has become much harder to further adapt to changing needs, changing hardware, and the changing programming constructs. And over that same period of time, the fit, value, and agility has decreased. So we are in a right mess. We have this great piece of software, this crucial piece of software that we all rely on, and it is one very big bowl of spaghetti. So what to do? That was the question that Oracle had to consider, and probably even before Oracle, that Sun Microsystems had to consider. In order to propel Java into the modern era, it had to find a way to upgrade the C2 compiler, this just-in-time compiler. And that is one of the main aspects of Graal, but there are more. The first and foremost contribution that GraalVM is making is that it provides us with a modern C2 compiler, a modern just-in-time compiler that will, as I said, propel the JVM again. This is extremely important, and yet it's largely under the hood, so you may not care all that much. GraalVM, its tagline is run programs faster anywhere. And note, it doesn't say just Java programs, and we'll talk about that a little bit later on. So it increases application throughput and reduces latency for Java applications, and especially for modern Java applications that make use of programming constructs, for example, such as streaming, that didn't exist in 1999 and that weren't handled all that well by the old hotspot just-in-time compiler, but they are handled very well by the GraalVM just-in-time compiler. Here are some statistics, and you don't have to look at all these graphs in detail. They all indicate that running on GraalVM is much better than running on the traditional hotspot JVM. And that's both in terms of throughput and performance. So without doing anything except switching from the hotspot JVM just-in-time compiler to the GraalVM just-in-time compiler will give you benefits. They're not orders of magnitude. It might be 10% or 20%, but still it's a gain that you get for free. If you look at the chart in the lower left-hand corner, it's on Scala. Anyway, you're wondering why Scala? Well, Scala is a JVM language. It gets compiled to Java bytecode or to bytecode that we can consider Java bytecode. It runs on the JVM, and it runs faster on the JVM than on the GraalVM JVM than on the hotspot JVM. And this was a reason for Twitter to very early on start adopting GraalVM. So even as early as 2017, and it was talked about in 2018, Twitter indicated that they had started using GraalVM for running all their Scala applications. And it gave them a benefit of 13% CPU usage. It basically meant a huge cost saving and also a huge increase in stability and manageability. So what Twitter did already in 2017 is something that we all can do, and we probably all will do in times to come. So here is a little bit of history. GraalVM comes out of Oracle Labs, and if you ask me, it's one of the coolest technical innovations created by Oracle in the last 15 years. I'm not overly impressed with the innovation that's produced by Oracle, but GraalVM is one of the exceptions. It's a great piece of innovation. So it was started already back in 2012. It was launched officially, so the first GA release back in 2018, and last August we saw the 20.2 major release. And there's a long roadmap with many new capabilities coming on. Twitter was there very early on, so they started using GraalVM back in 2017, and of course they are a major proof point. If they can do it, you can do it, and I can do it. And then there are all these other events that took place, products that are certified against GraalVM, frameworks that really only exist because of GraalVM, and I'm going to explain more about that later on, and support in GraalVM for various other languages that are distinctly not JVM languages, such as ECMAScript or JavaScript, Node, which of course is the ECMAScript runtime for the server side, and Ruby. Again, I'll talk about those in a while as well. Now, I'm not sure I will have time in this session to actually show you any demos, but you can easily try out GraalVM yourself without having to install anything locally. If you go to this URL, and I've also pasted the URL in the chat, you will go to this site, and in this site you get a complete hands-on tutorial, including an environment in which to run the hands-on tutorial. So there we go. Here we are in an Ubuntu virtual machine, and by pooling this Docker container image that contains the full-blown GraalVM Community Edition release, you can start trying out GraalVM right away. And this tutorial leads you through all the steps to get a good feel yourself for what GraalVM can do. Maybe at the end of the presentation, I will have a little bit of time to actually show you something, but for now, I'll just continue with my story. We're going to talk about fancy things. So GraalVM is very fancy under the hood because it runs modern Java applications faster and more stable than the old hotspot JIT compiler does. But there is more to GraalVM, more that will excite you. So there's support for native image generation, there's support for polyglot languages, and there's support for interoperability between all these languages. And I'll talk about this in more detail. So you probably have heard the term cloud native, and you know about containers and microservices and serverless functions and automated continuous delivery. And in order to actually be cloud native and run serverless functions and make use of microservices, we have a number of desires. We want a small application footprint for our functions, for example, for the containers. We want to have simple and small and easy to manage runtimes. We will probably have stateless applications that are focused on single request or event handling and are not long running. We want to have, of course, fast execution, and we certainly want to have a rapid startup of our application because the application will handle only one request or event, and it will run as a function, and it shouldn't take long for the function to even get started. And all of this doesn't really sound very much like Java as you know it, or does it? So initially, when people looked at cloud native and looked at all these modern concepts, they didn't tend to look at Java, which of course is a pity because Java is a great programming language. And now, thanks to Graal, all of this very much is Java. And you see here a number of technologies and frameworks that all benefit from GraalVM in order to achieve all of this. So a small application footprint, a simple runtime, stateless handling, rapid startup, fast execution. You can all do it with Java thanks to GraalVM and thanks to the native image generation capabilities of GraalVM. Okay, what the heck is native image generation? What is it? A native image is just a binary executable, a simple .exe file, and you can run it on a simple operating system. You don't have any special requirements for that operating system. Could be Windows, could be Mac OS, could be Linux, and you don't have to install a Java runtime environment. You don't have to install the full JDK. You don't have to install anything. You just have your Linux operating system. A very small Linux operating system suffices. And of course, this can easily be used in a container or a serverless function. Binary executable, no special requirements on the operating system, no additional runtime dependencies. And additionally, this executable has a very small startup time, has a very small footprint. The exe file itself is very small, and the requirements in terms of memory usage are very small, not very much smaller than a regular Java application. The environment, as I mentioned, is extremely simple and small and easy to set up and manage and maintain, and execution is very fast. And we typically will want to use a binary executable for fast single request handling or event processing. It's not for stateful and long-running applications because we don't get happily ever faster thanks to our JIT compilation in a binary executable. The binary executable has a single code path that has been baked into the executable, and there's no link to the original Java code, and there's certainly no just-in-time compiler available. So for a Java application that keeps on running for long periods of time, hours or even longer, you wouldn't use a binary executable, but for serverless functions that very rapidly start up, execute, and complete, you want to use a binary executable. Typically, with Java applications, we have a design time and a runtime. And at design time, we create code, we program Java, we compile the Java to a .class file, our Byte code, and then we package all of that into a jar file or a war file or an ER file. And at runtime, we need a Java virtual machine, That's our runtime environment, which is not a simple environment. It's also not a small environment. And in this environment, we will first have our bytecode interpretation. So we start, it's not we, it's the Java virtual machine that starts interpreting the Java bytecode and executing it line by line. And over time, we will get our tiered just-in-time compilation, turning pieces of Java bytecode into machine code, and eventually we will just be executing machine code. But it takes quite a while for our application to become compiled to machine code. So it will take quite a while for the application even can start, because the startup time for the Java virtual machine and the initial slow bytecode interpretation. So only after minutes or hours will our application actually be running at speed. So that's the situation we currently have with regular Java applications. And with the uh, GraalVM native image, what we do is, well, we of course still code Java, and we compile our Java code to Java bytecode in classes, and then we can generate a native binary image. This step is quite complex and takes quite a while, minutes, to get from our bytecode to our native binary image. Of course, this is not something we have to do all the time. We only do this when we are at a point where we want to deploy our code. Once we have the native binary image, we can run it. And we can run it in an environment, well, that doesn't contain a Java virtual machine. It doesn't contain anything except for the operating system. And it immediately starts executing machine code, because that's what's in the native binary image. So you can see what's going on here. We have shifted some of the load that we used to take at runtime. We have shifted it to design time. At design time, we take the hit, and at runtime, we benefit from taking that hit over and over and over again. We don't get any speed up, but for Java application that will only run for a short time, such as serverless functions or even our containers, it's okay that it doesn't get any faster, because it, it won't be running for long enough to actually benefit from getting faster. Now, when you compare native images versus traditional JVM just-in-time compilation, so ahead of time compilation, AOT versus just-in-time compilation, we get much faster startup times, which is understandable because we don't really have to start up anything. We don't have to start up JVM. We can immediately start executing machine code. And the memory footprint, which is one of the factors on which the pay-per-use is based for serverless functions, the memory footprint is also much smaller, 5 times smaller on average. Additionally, which I also think is very important, the environment that we need to set up for running a native image is extremely simple. It's only the operating system, whereas the environment we need for running a Java application can be quite complex, especially if we have to provide all the dependencies of our Java application in addition to the application itself and in addition to the JVM. So native images for Java applications, thanks to GraalVM, have really opened up a tremendous world. And many frameworks are now benefiting from this capability. Very briefly on the ahead of time compilation process. So this is where we generate the native binary image. What's happening is that GraalVM is taking the application itself, the classes of our application, the libraries our application depends on, the JDK libraries, and then a very small virtual machine that's part of the GraalVM stack, the substrate VM that has capabilities for interacting with the file system, for example. All of these are taken together. Then GraalVM will do an extensive analysis of our Java code to find out all the dependencies, all the classes in the libraries and the JDK that are needed at runtime. And then it will do the translation of the Java bytecode to the machine code, the same that would happen otherwise at runtime in the JIT compiler. It's now taking place at design time. You can also understand why there are some limitations on this process. All the dependencies of our Java code need to be known at analysis time, because all the classes that we need to rely on in our Java code need to be translated into machine code. And if some of our dependencies are resolved dynamically at runtime through reflection, for example, that makes it very hard, if not impossible, to create machine code that's complete. And this is one of the reasons why it has taken quite a while for the Spring framework to support native image generation. But now with Spring 5.3, it does support native image generation. Okay, so that's one very fancy aspect of GraalVM, this capability to generate native images. Java infrastructure has long been the envy of the world. Java code, you write it once, you run it anywhere, and the JVM is very stable, and the JVM has many capabilities and tools to monitor it, to tune it, to profile it, to debug it. I've heard a story, and I'm not quite sure whether it's true, and I couldn't find any references. But the story went as follows: at Spotify, when they want to do innovation, they program in Node.js. But once they want to really productize the things that they have innovated, they re-implement using Java, because they can run Java at scale, at enterprise scale. I'm not entirely sure this story is correct, but it certainly could be. So the Java runtime infrastructure is the envy of the world. That's nice for Java, and that's not so nice for the rest of the world. Or is it? So this very simple cartoon, the programmer's life, at work, at home, when playing, and when sleeping. Actually, the dream of a programmer, if Java really is the envy of the world, could be something like, if only I could program in X, and I could apply all my coding skills in X, and I could import existing code that I already have written in X, and I could leverage libraries, third-party modules, and native features of X. But then when it comes to the runtime, I would be able to run on an enterprise-grade, fast and stable VM with tools to perform operations with. Wouldn't that be great? And that exactly is the second fancy feature that GraalVM is offering. It doesn't just run Java code or other JVM languages, such as Scala, Groovy, and Kotlin, but it is polyglot. It understands multiple languages, and it can run multiple languages. So even though GraalVM is a VM that runs Java bytecode, it can also run programs that have been programmed in X, where X can be Node, Python, Ruby, R, or other languages. So when we take a somewhat broader look at GraalVM, yes, it's the just-in-time compiler, and there's the substrate VM that we use for the native images, but there's also the truffle framework, and the truffle framework, simply put, can take a program programmed in any of these languages and turn it into something that's very similar to Java bytecode that can be executed by the Graal compiler. So you write Python, it's turned into something that resembles Java bytecode, and the GraalVM can run it. So GraalVM can run programs in many different languages. That's why we call it the polyglot VM. It's like the reverse of the Babel Tower. Instead of forking different languages from each other, it's bringing them back together. So this is one way of describing it. All these languages are turned into Java bytecode, and they can be run on the JVM. Nothing very special there. But all these languages, through the truffle framework, are also turned into Java bytecode, or something that at least resembles Java bytecode, and can be run by the Graal compiler as well. And even these languages, through Solong LLVM, that's also a way to create bytecode out of these languages, can also run on the, uh, the on GraalVM. So with one runtime framework, one set of tools, and one GraalVM, we can run almost any program that we write in almost any language. Not all of them, but many of them. So that's the second very fancy thing of GraalVM. And for those of you who are Oracle database users, the next version of the Oracle database, 21C, will have the multi-language engine, which allows us to create stored procedures in JavaScript and Python. And these will be run using GraalVM. And there's no reason why eventually also Java stored procedures, Ruby stored procedures could be supported as well. Do you know the situation where you're looking for a word, an expression? You want to say something, you are talking in Dutch in my case, or in English or in German, as in most of your cases, and you can't seem to find the best way of putting it. And then you might borrow from another language, because in this other language, it's easier to convey the feeling. There's a better way of expressing it. And these are just some examples. In Dutch, we tend to use the German word überhaupt quite a bit, because we don't have a Dutch way of saying something so in such a compact way. Now, in programming, there's something similar. The grass is sometimes greener in another programming language. You're working in, say, Java, but you know that this other programming language is so much better at encryption or at validation or at text manipulation. And this other language has great libraries for machine learning. Or this other language is the one that's used by our domain experts, and we would like to incorporate their work into our application. Or this other language was used to implement modules that we would now like to reuse. But it's another programming language, it's another world, and it's another law. That's the way it used to be. And that's the third very fancy thing that GraalVM is offering us. It will allow us to interoperate languages with each other. So instead of having languages on one side of the fence and on the other side of the fence inaccessible to our side of the fence, actually what we get is the ability to, for example, have Node.js and Python on the other side of the fence. The grass is greener on the other side of the fence. Actually, there is no other side of the fence. We can now reach out from our Java application to code written in Node and code written in Python, or vice versa. So polyglot interoperability allows us to have frictionless interaction between language contexts. And that's something that you can have between humans, but in our case, we have it between programming languages. How can that be? How can you even imagine something like that? Well, actually, it isn't all that hard. People speaking in different languages can still find a way to communicate. I think in Dutch, I speak in English, you probably think in German, but can still understand, hopefully, most of what I'm saying. And in your head, you probably translate it back to German. And it's all possible because, well, we all use words. We use the same concepts and structures in language. We all use similar grammar, or at least I think it applies to all languages shown on this slide. And the same thing basically applies to programming. We all use similar concepts in our various programming languages. And even though the syntax is slightly different and the layout is slightly different, and the standard libraries we are using are different, the basic abstract concepts are the same. And in the case of GraalVM polyglot interoperability, the truffle framework takes all of our languages and converts our programs into abstract syntax trees that are composed of these core concepts. Back to the foundational level where you will have variables and loops and conditions and calls and basic arithmetic, and all our programs are composed of such concepts. So when our programs have been translated into these core concepts, they are all very similar. And the fact that one originated from Python and the other one originated from Java isn't all that visible anymore, or isn't visible at all. So that's basically what's happening at a low level, but we don't really need to know all that. Although it's nice to understand in order to be able to rely on it. So GraalVM can merge at runtime code from various origins. So I can create a Java application, and in my Java application call out to JavaScript code, call out to Python code, call out to Ruby code or R code, and also the other way around. So I can also create a Node application, in my Node application call out to Java code, or Scala or Kotlin code, or Python code, and vice versa. This is what we call interoperability. So I'm going to show you some code. If you don't like code, this is a warning. If you do like code, sorry, it took me so long, but maybe you're already hacking away at the hands-on environment. So here's code. This is Java code. And in my Java code, I want to execute JavaScript. And of course, the first example is an extremely simple example. What I need to do in my Java code, and by the way, the same code is part of the hands-on tutorial that I just referred you to. In this Java code, I'm importing the Graal polyglot package. That's what's happening here. Next, I'm creating something called a polyglot context. And this polyglot context, which is called polyglot, is something that allows me to evaluate pieces of program code in different languages. So in this case, there's a very small section of JavaScript code. It's print hello JavaScript. Well, print is not a statement in Java. And I'm here specifying to the polyglot object that the language that I wanted to evaluate is JavaScript. It could also be Ruby, it could also be R, it could also be Python. In this case, it's JavaScript. It will be executed, and it results in hello JavaScript being written to the console. In Java, this would have been sys out println hello JavaScript. Have I gained much? Well, of course I haven't in this specific example, but now we have unlocked the world of JavaScript in Java. Here's another example, slightly more interesting. Here I'm again evaluating a piece of JavaScript, but it isn't actually executing anything. It is creating a function, and this function is returned as a result. So in JavaScript, I create a function that when executed returns a string, but at this stage, it only returns, this eval statement only returns the function itself. So this function is now in this hello world function variable, and this variable contains something I can execute because it's a function. And that's what's happening here. Hello world function dot execute, and I pass in a parameter John Doe. This will make a call to the function that was defined up here. And the result of that function is stored in this string. This string is written to the console, and there is the result. The result itself isn't spectacular, but what we are doing here is quite spectacular, I believe. We create a function using JavaScript code, and this function can now be invoked in Java as if it were a Java method. And here's a third example of throwing an exception in JavaScript and handling this exception in our Java code. And again, the example itself is not very special. The mechanism, I think, is. So here's a slightly more interesting example. I'm developing a Java application. And in my Java application, I need to perform validation on various types of data, on postal codes from various countries, on mobile phone numbers from many different countries, on email addresses, credit card numbers, etc. And of course, I could create this code myself, but it turns out that there is an NPM module, the Node Package Manager has a module that offers all of these validations and more out of the box. That's great. However, NPM modules are written in JavaScript, and I'm developing a Java application. So how is this functionality of any value to me? Well, I could look in the JavaScript code and see what a postal code in Albania is supposed to look like and use that to implement my own validation in Java. Or I can do better. And of course, I can do better. I would like to use this NPM module and then create pseudocode that would look something like this. I have a postal code validator, not sure where it comes from, but it comes from somewhere, and I can execute it with a certain postcode value. And in this case, it's my own postcode, and this is the Dutch. I want to know whether this is a valid Dutch postcode. This is pseudocode because I don't have a postal code validator. Of course, you know where I'm going with this. I'm going to create a postal code validator using this NPM module and using GraalVM polyglot interoperability. So first, let's check out if I indeed have a postal code validation method in my NPM module implemented in JavaScript. And there it is. So that looks great, is postal code. I would like to have that one available in my Java code. Let's check at the GraalVM website whether this particular NPM module is suitable for integration into a Java application using GraalVM polyglot. And yes, it is. Well, that's good news. Now, very quickly, the steps I need to go through, and that's a bit much for this presentation, but you can also find it in the hands-on tutorial. So first, I need to decide that I will be using the GraalVM JVM as my runtime for Java applications. Then I install NPM and the NPM module validator. Then I use Webpack to turn this NPM module into a single very big JavaScript file. And then I'm going to extend my Java application. I need to import the polyglot package, as we saw before. I need to create the JavaScript polyglot context, which we saw before. I need to load the validator .js single file with the entire module into this context object. And then I get the desired functions from the bindings map, and I will show you that in the next slide. And then I can execute these JavaScript functions as if they were Java methods. So there we go. I import the polyglot package. I create a context. I load the full JavaScript file into the context. And from this context, I get a list of all the member keys, which basically gives me a list of all the functions that are defined in this JavaScript module, and that are now available as methods in my Java context. From the context, I get the member that's called isPostalCode. This is a function. Now this function is in my postal code validator variable, and here I can execute this variable. So before it was pseudocode, and now it's real code, because the postal code validator is an object that I can invoke, even though in my Java context, even though it's based on JavaScript code. So I don't have to understand the JavaScript implementation of this validation. I don't have to look up the correct postal code format for the Netherlands or any other country. I can just benefit from one of the more than 1 million NPM modules from the context of my Java application. Another of the benefits of GraalVM.
Luca, sorry to interrupt you. We have 2 minutes left, so maybe there are some questions.
I will quickly wrap it up.
Okay.
It's okay. So here's an example of this polyglot feature actually being used at the Dutch National Police. They have developers who write in Scala and data scientists who are using R. They couldn't work together before, but now they are working together thanks to GraalVM interoperability. Coming to my conclusion, what's GraalVM? It's the new just-in-time compiler. It's the polyglot runtime that offers a runtime infrastructure to all different programming languages. It allows the generation of native images. It supports interoperability between different programming languages. It allows you to create a custom DSL, domain-specific language, that can also be executed on the GraalVM JVM, and it comes with a slew of tools that will support you in your operations. Okay, I think that's basically what I needed to say. So, Volker, what are the questions?
So let me look in the chat. So I haven't seen any question regarding this topic. I think you have explained it very well, and it was clear for me. But if anybody has some question, please drop your question in the chat. And if we could not answer, maybe you can send the email your question directly to Lucas.
Yeah, sure.
So I don't see any questions at the moment.
So maybe then I aborted a little bit.
So we're just in time finished. So it's 2:45. So maybe you can say the last words.
Well, you should be aware of the fact that GraalVM comes in 2 editions. One is free, that's the community edition, which is good enough in most cases, but there's also a commercial edition supported by Oracle. You get it for free on the Oracle Cloud. But if you're not on the Oracle Cloud and you want to use the Enterprise Edition, you do have to pay support fees for it. I want to urge you to start using GraalVM, if only with baby steps. At least use it as your JVM, because it really is the next generation of JVM. You can look at the native image generation to see if it will give you any benefits. Especially if you want to use containers, serverless functions, it will certainly give you benefits. And it's also very interesting to take a closer look at polyglot, the interoperability between languages. And with that, I would like to thank you for your attention. I want to point you to the slides. They are available for download. And again, at the environment where you can play with GraalVM. Those were my last words, Volker. Thank you very much.
Thank you very much for the lovely talk. So I will stop now the broadcast. Thanks for your participation.